Hello friends, myself Rajendra Mahajan presenting my new video on Fourier transform. Example, find the Fourier cosine transform of f of x is equals to e raised to minus x square. Watch the video completely for better understanding or clear understanding. As here we require to find Fourier cosine transform of the function f of x is equal to e raised to minus x square. It is obtained by the formula fc lambda, f capital, suffix c. C stands for cosine transform. Therefore, that fc lambda is equals to square root of 2 by pi into integration from 0 to infinity of f of u into cos of lambda u du. Therefore, once again I will repeat that formula. Fc lambda is equals to square root of 2 by pi integration from 0 to infinity f of u into cos of lambda u and its integration with respect to u. Substituting the value of f of u by replacing x by u in that f of x, we get fc lambda is equals to square root of 2 by pi integration from 0 to infinity f of u is e raised to minus u square into cos lambda u du, and we call this as equation number 1, where we consider, let us consider that integral as I of lambda as integration from 0 to infinity e raised to minus u square into cos lambda u du as equation number 2. We require to obtain the value of that I of lambda. Therefore, put lambda is equals to 0 in equation 2 at this step or at the end of the calculation. Here I am substituting immediately. Therefore, left hand side becomes I of 0 is equals to integration from 0 to infinity e raised to minus u square and cos 0 and its integration with respect to u. But the value of cos 0 as 1, and therefore that integral becomes integration from 0 to infinity of e raised to minus u square with respect to u. And to evaluate this, we call this one as b, suppose. We have to substitute u square as some new variable t. Differentiating it with respect to u, we get 2u du is equals to dt. New limits for u is equals to, therefore du is equals to dt by 2u. And therefore, the value of u is square root of t. Therefore, it becomes dt divided by 2 times root of t. New limits for u is equals to 0, we get t is equals to 0, no change in the limit. And for t, u is equals to infinity, we get t as infinity, again no change. And therefore, substituting all this information in that equation b, we get the value of I of 0 as integration from 0 to infinity, no change in the limits, e raised to minus t, and du is dt divided by 2 times root of t. Rewriting it, taking 1 by 2 outside the integral sign, therefore it is 1 by 2 integration from 0 to infinity e raised to minus t into t raised to minus 1 by 2 dt. Then rewriting that by adding 1 and subtracting 1, so that it becomes e raised to minus t, t raised to minus 1 by 2 plus 1 and minus 1. dt, nothing but 1 by 2 integration from 0 to infinity e raised to minus t raised to 1 by 2 minus 1 dt. This term is similar to the definition of gamma function. We know that integral from 0 to infinity of e raised to minus x, here it is e raised to minus t, some x raised to n minus 1, integration with respect to x has nothing but gamma n. And therefore, here the value of that n is 1 by 2. And therefore, that I of 0 becomes 1 by 2 gamma of 1 by 2. But the value of gamma 1 by 2 is square root of pi divided by 2, and we call this equation C. Then differentiating equation 2 with respect to lambda, we get derivative of I of lambda is I dash of lambda, and on right hand side it is partial derivative, therefore dou by dou lambda of integral from 0 to infinity e raised to minus u square into cos lambda u du. Therefore e raised to minus u square cos of lambda u du. Then applying differentiation under integral sign technique or theorem, we can interchange that two operators of derivative and integration. Therefore, interchanging that operator, taking outer as integration operator and inner as differentiation operator. Therefore, integral from 0 to infinity dou by dou lambda of e raised to minus u square cos lambda u, and then its integration with respect to u. With respect to lambda, e raised to minus u square is a constant term. Taking outside the differentiation operator, and derivative of cos lambda u as minus sin lambda u, and chain rule, derivative of lambda u with respect to u is with respect to lambda is u, and then its integration with respect to u. Here minus sign we can take outside, and we make a product of two terms. First one as sin lambda u, and second as u into e raised to minus u square as a second term, and its integration with respect to u. And as it is a product of two terms of u, applying integration by parts for this equation number 3. Sin lambda as first function, u e raised to minus u square as second. Therefore, in that parts we require to find the integration of the second term. We perform that calculation separately by substituting u square as t. Differentiating with respect to u, we get 2u du is equals to dt. U du is equals to dt by 2, and therefore that integral becomes u du nothing but dt by 2 and e raised to minus u square, it becomes e raised to minus t. Therefore, integration of e raised to minus t into dt by 2, 1 by 2 take outside, integration of e raised to minus t is e raised to minus t upon minus 1, nothing but minus of substituting value of t as minus u square, we get minus e raised to minus u square by 2. Using this value in that integration by parts result, we get I of lambda is equals to I dash of lambda is equals to in bracket minus outside. First term sin lambda u as it is, no change. Integration of the second term, which we have calculated separately as minus e raised to minus u square by 2 limit from 0 to infinity minus integration from 0 to infinity derivative of sine as cos lambda u into lambda, and integration of second again, it is minus e raised to minus u square by 2. This one is the integration by parts, and then substituting the upper and lower limit, we know the value of e raised to minus infinity as 0 and sine 0 as 0. Therefore, using these two values in that result, we get I dash of lambda as minus as it is, no change. For upper limit, it becomes 0, and for lower limit, again 0 plus 0 minus, and that minus it becomes plus lambda outside, lambda by 2 outside, integration from 0 to infinity of e raised to minus u square into cos lambda u du. This is nothing but I of lambda, and therefore we get, this one is plus, yes. Multiplying by that minus sign, we get that term as minus lambda by 2 into I of lambda. This term is nothing but integral I of lambda. Then I dash means di by d lambda is equals to minus lambda by 2 into I. Then separating the variables, collecting I and di on one side and lambda and d lambda on other side, we get di by I is equals to minus lambda by 2 into d lambda, and then integrating it. Integration of the first means left hand side is log I, integration of right hand side is minus 1 by 2 lambda square by 2 plus constant c. Then transferring log to right hand side, we get I is equals to e raised to minus lambda square by 4 plus c, splitting it as e raised to c into e raised to minus lambda square by 4, e raised to c some new constant, suppose a capital, into e raised to minus lambda square by 4. Equation number 4th. And on left hand side it is I of lambda. Then substituting lambda is equals to 0, in that 4th we get a is equals to I of 0, but the value of I of 0 is square root of pi by 2. Therefore, we get the value of a as square root of pi by 2. And substituting this in equation 4th, we get I of lambda as root of pi by 2, root pi divided by 2 into e raised to minus lambda square by 4. Then using this in equation 1 to find out Fourier cosine transform, nothing but fc lambda. Therefore, we get the value of fc lambda as square root of 2 by pi as it is, and into the value of I of lambda, it is square root of pi divided by 2 into e raised to minus lambda square by 4 as a required answer or required value of that square root get cancel. We get 1 by root 2, 1 root get cancelled, 1 by root 2 e raised to minus lambda square by 4. Please like my video, share it as well as hype the video then subscribe to my channel and press the bell icon to receive the notification. Thank you. Thanks for watching.